What's up, everyone? This is Dr. Jax. Today, we're going to be looking at how we solve for the force exerted by a rocket in order to launch and overcome gravity. In order to do this, what we're going to do is look at the change in distance as well as the time, which are on your screen. At the point of launch, what you want to do is look at the time of launch as well as whenever you pause the video and look at the distance that the rocket has traveled. Based on those two things, as well as the mass, which you're going to look up on your own, you'll be able to use the kinematics equations to calculate the acceleration. And then after that, you can use the acceleration to find the net force and compare that to the weight of the rocket in order to determine the overall force that the rocket must exert in order to launch. When we're doing this, we're going to make two assumptions. The first is that we're going to assume that there is no air resistance. And the second is that we're going to assume that the rocket is accelerating uniformly over the time that you see on the screen. So with that, let's launch.
Six, five, four, three, two, one. Main engine start, zero, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary.
All right. And so based on what you saw here, what I suggest you do is you pause the screen or slow-mo it in order to determine the actual change in distance. Use an even number like 100 meters or 50 meters, something nice so it's easy to work with the math. And what you're going to do is basically work backwards in order to find the overall force of the rocket.